Right, so this is Science Paper 1, 2023 GCE. So in this video, I'll be answering section B and section C, all the questions. Okay, so let me start with question B1. Okay, so question B1 came from mass and density. Okay, mass, volume, and density. Okay, so if you are new to this channel, kindly subscribe for more videos and also share the video if you find it useful. Okay, so let me start with the first one. So the question is saying a learner carried out an experiment and obtained the following results as shown. Okay, so as shown. So a learner carried out an experiment and obtained the following results as shown. So now the condition here is that where necessary, we need to take the density of water. So I want you to understand on this part here, where necessary, we need to take the density of water to be 1 gram per centimeters cube. Okay, so 1 gram per centimeters cube is the density of water, only water. Okay, so they are saying the mass of an empty bottle, which means the empty bottle without water inside, okay, it was 80 grams. Then the mass of the bottle full of water, which means the mass of the bottle full of water, it was 20 grams. Now this means that in these 20 grams, we have two things: the mass of the empty bottle and also the mass of water. So now, since we know the mass of the empty bottle, which is 8 grams, so which means for us to find the mass of water, we are going to say 20 minus 80 grams. Then the answer is going to be 12 grams. These 12 grams will be the mass of water only. Okay. Then the next one, we have the mass of the bottle full of liquid X. So the mass of bottle, the mass of bottle full of liquid X, it is what? 25 grams. Now, in these 25 grams, we have the mass of the empty bottle, which is 8 grams, and also the mass of liquid X. Now, for us to know the mass of liquid X here, we are going to do the same thing. Okay, we are going to do the same thing. We are going to say 25 minus 80 grams. Then the answer is going to be what? 17 grams. 17 grams is the mass of liquid X only. Okay, so here we are dealing with masses. Okay, so now the instrument that we can use to measure the mass of an object, it is the beam balance or the triple balance. So in an exam, they can also ask you to define what mass is. So mass is the quantity of matter contained in an object. So mass is the amount of, the quantity of matter contained in an object. And the mass is measured in where? In kilograms. Now on this part here, when you're dealing with mass, volume, and density, mass is measured in where? In grams. Only when you're dealing with density. Okay. So the first question, which is question A, it is saying, name the instrument that can be used to obtain the results of mass. So here they are just asking you to give them the instrument that we can use to measure the mass of an object. So the answer here, it is going to be what? The beam balance or the triple balance. Then apart from that one, we have question B. So question B is saying, calculate the volume of the bottle. Now, when calculating the volume of the bottle here, you need to have two things. The first one, you need to have the density. Apart from having the density, you need also to have the what? The mass. Now, in this question here, they were saying, where necessary, we need to take the what? The density of water, not the density of the full bottle of water. Let me say, not the density of bottle full of water, but the density of water only to be 1 gram per centimeters cube, which means here they are asking us to calculate the volume of water. Okay, not the volume of water in the bottle or the volume of the bottle full of water? No, they are asking us to calculate the what? The volume of water only. Okay, so here I'm going to say, since I know that density is equal to mass over volume, so I'm going to say density here, I'm going to use now the density that have been given in the question, which is 1 gram per centimeters cube. So in your answering, you need also to put the what? The units while you are answering. Okay, so I'm going to say 1 gram per centimeters cube is equal to mass. Now this mass here, I'm going to say 20 grams minus 8 grams. This 8 grams, I'm subtracting the 8 grams of the empty bottle so that I remain with what? The mass of water only. Okay, so I'm going to say the mass of the bottle full of water, which is 20 grams minus 8 grams of the mass of an empty bottle over volume. So I'm going to say volume multiplied by 1 gram per centimeters cube. The answer is going to be what? 1 gram per centimeters cube. V is equal to, we have 20 grams minus 8 grams. The answer is going to be what? 12 grams. Then from there now, since I'm looking for volume, which is V, so I'm going to divide by 1 gram per centimeters cube divided by 1 gram per centimeters cube. So gram per centimeters cube and gram per centimeters cube, they are going to cancel each other. Then here I'm going to remain with what? V, which is the volume. So my volume is going to be 12 grams divided by what? 1 gram per centimeters cube. So the gram from 12 is going to cancel with the gram from 1. Okay, so here on the bottom I'm going to remain with what is 1 centimeters cube. So 1 centimeters cube into 12, I'm going to get what? 12 centimeters cube. So our volume here, it is going to be what? 12 centimeters cube. Then the next one, which is question C. Question C reads, calculate the density of what? Liquid X. Calculate the density of liquid X. So I'm going to say the density of liquid X is equal to mass over volume. Now, do we have volume here? Yes, of course we have. We are going to use the volume from question B, which is 12 centimeters cube. So I'm going to say density is equal to mass, which is 25 grams minus 8 grams of the empty bottle, so that I remain with what? The mass of liquid X. So I'm going to say 25 grams minus 80 grams, I'm going to get what? 17 over 12 centimeters cube. So if I divide 17 grams divided by 12 centimeters cube, I'm going to get what? 1.42 grams per centimeters cube. Remember, density is measured in where? In grams per centimeters cube. So if you forget to put the units, which means the answer is going to be wrong. Okay, let's move on to the next one, which is question B2. So question B2, this question B2 is coming from where? Stability. So now, stability is the ability of an object to regain its original position after being displaced slightly. Okay, so stability is the ability of an object to regain its original position after it has been displaced slightly. Okay, now under stability we have 3 types of stability. The first one here, it is stable stability, followed by unstable stability. Then the last one, which is neutral stability. Now this question here, it is saying figure B2.1 shows some cone being placed in 3 different positions. So we have X, Y, and Z on a front surface. So cone X was pressed on the tip of of the cone, resting on the surface. So as you can see here, cone X was placed where? On the tip of the cone, resting on the on the surface. So we can say on cone X, this one here, it is unstable. The reason why I'm saying this one here, it is unstable stability, this is because the base area, it is what? It is small. The base area is small. As a result, this one here, if we push it, it can fall down very fast. Okay. Then as for Y, Y is saying cone lying on the surface. So now, as you can see, this cone Y here, it is lying where? On the surface, which means this one here, it is neutral stability. Okay, neutral stability. So now, when you talk of neutral stability, you are going to find that if you lift this cone here from the tip, you are going to find that the cone is going to be stable. Now, if you lift this cone Y from the base, you're going to find that it will become now unstable. So that's the reason why I'm saying cone Y, it is a neutral stability, or it is obeying neutral stability. Then as for Z, base of the cone resting on the surface. As you can see on Z, it is having a large base area, which means this one here, it is stable. One thing here, what you need to understand is that the base area affects the stability of an object. If an object is having a large base area, an object is going to become stable. So if an object is having large base area, that object is going to become stable. But if the base area is small, an object is going to be unstable, like the way X is here. Okay, so the first question, which is question A, is saying define the center of mass. So in defining the center of mass, I'm going to say the center of mass is the point in an object or on an object where all the masses appears to be concentrated. So I'm saying the point in an object or on an object where all the masses appears to be concentrated. That one is the center of mass. Then the next one, which is question B, is saying identify the cone in a neutral equilibrium position. Now, when they say neutral equilibrium position, which means they are talking about neutral stability. Then here I was saying cone in Y, it is what? It is obeying what? Neutral stability, or we can say neutral equilibrium. So I'm going to say Y. So here just give them the letter, which is what? Y. Then question C is saying, state two factors that affect stability of an object. Now, when you talk of the factors, here they just mean like what is going to happen if you increase the base area. An object is going to be what? Is going to be more stable. Now, what if you reduce the base area? An object is going to become what? Unstable. So the first one here, I'm going to say the base area. The base area affects what? The stability of an object. How? Let's say, for example, if you increase the base area, if you increase the base area, an object is going to become more stable. But if you reduce the base area, an object is going to become unstable. So apart from the base area, you can talk of the center of gravity. So if you increase the center of gravity, an object is going to become unstable. If you increase the center of gravity, an object is going to become unstable. But if you reduce the center of gravity, an object is going to become what? Stable. For example, like the way the racing cars are. The racing cars, they have what? They have low center of gravity. That's the reason why they are stable than those my big buses like power tools. Okay, so that was the last one for question B2. So let's move on to the next one, which is B3. So B3 is coming from where? Forces. B3 is coming from where? Forces. Okay, so the first question here is saying, or the question is saying, figure B3.1 shows the direction of four forces acting on a car whose weight is 8,000 newtons. So here we can say the weight here it is what? 8,000 newtons. So we can collect the data here. So weight is equal to what? 8,000 newtons. As it travels in a horizontal straight line. Okay, straight what? Line. So we have force A acting vertically upward. Then we have also force B acting horizontally forward. So as for force B, this force B, it is exerted by the what? By the engine from the car, or the car engine. Then as for force C, this force C, it is acting downward. It is the gravitational force. Then as for D, this force D, it is the air resistance. Okay, so force D, it is the what? The air resistance, which is opposing the what? The motion. Okay, so as for the first question, which is question A, saying, what two forces should be equal for the car to move at a constant velocity? So now, when the car is moving at the constant velocity, you are going to find that the force which will be exerted by the engine will be equal to the force which will be exerted by the what? By the air resistance. So as for force B, it is the force which is exerted by the what? By the engine. Then as for force D, it is the force, or it is the air resistance. So which means here I'm going to say force B and force D should be equal. Then as for question B is saying the following table B3.1 shows sizes of forces acting on the same car after it had covered a certain distance. So here we need to take G as 10 newtons per kgs. So G, it is the gravity of the earth, which is what? 10 newtons per kgs. So we need also to correct this one here. So I'm going to correct here. Okay. So this one would be also our data. Then they are saying force A, which is the what? The force acting upward. So now, as for force A and force C, can only act on an object which is at rest. Okay, so force A and force C will only act to the object which is at rest, not the object in motion. Okay, so as you can see, this car here was in motion, so which means as for force A and force C, we need to exclude them. Okay, so we have force A having the force of what? 800 newtons. So the engine is producing what? 800 newtons of force. Then as for force B, it is the what? Let me say force A, it is 800. The force which is acting upward when the car is at rest. Now this car is not at rest. Then as for force B, it is producing what? It is having the force of what? 1000 newtons. So 1000 newtons is produced by the what? By the engine. 1000 newtons is produced by the what? By the engine. Then as for force C, we have what? 8000. Now for C, it is the force acting downward when the car is at rest. Now this car here, it was moving. Okay, so mind you, this car here was moving. Then the last force, which is force D, it is what? 600 newtons. 600 newtons, it is the force which is acting, which is opposing the motion. In this case here, it is the what? The air resistance. Okay, so the first question is saying, calculate Roman numeral number 1, the mass of the car. So now in this question here, they were saying this car here, it has the force, it has the weight of what? It has the weight of 80,000 newtons. And we need to take G to be 10 newtons per kgs. So now, since we know that weight is equal to what? Mass multiplied by gravity. So I'm going to say weight is equal to mass multiplied by gravity, where weight is equal to what? 8,000 newtons is equal to mass we don't have multiplied by gravity, which is 10 newtons per kgs. Okay, then from there now we are going to divide by 10 newtons per kgs, even here 10 newtons per kgs. So here we are going to remain with what? M, which is the mass. So our mass here is going to be what? 800 kgs. If you divide 8,000 divided by 10, we are going to get what? 800 kgs. So our mass here is going to be what? 800 kgs. Okay, then as for Roman numeral number 2 is saying the resultant force on the car. So the resultant force on the car, here the car was in motion, right? The car was in motion. So I was saying we need to ignore force A and force C, because this force A and force C can only apply when this car was at rest. Now this car here was in motion. So which means here we are going to consider force F and force D. Now as you can see, force B is going forward, or it is the force which is applied by the what? By the engine. Then as for force D, it is opposing the what? The motion. Okay, so here, for us to answer this one here, we are going to consider the what? The directions. So force B is going where the car is going, which means This one here, it is the force which is produced by the engine. Then as for force D, it is opposing the what? The motion. So now for us to know the resultant force here, we are going to say resultant force is equal to, when the forces are acting to the opposite direction, you need to subtract by getting the bigger number, and then you remove the what? The smaller what? Number. So in this case here, force B, it is the force which is produced by the what? By the engine. So I'm going to say 1000 minus what? 1000 minus what? 600 newtons. So 1000 newtons minus 600 newtons. Then my resultant force is going to be what? 400 newtons. So the resultant force is more like the force, okay? So my resultant force is going to be what? 400 newtons. So if you forget to put newtons here, which means your answer will be wrong, okay? Then as for Roman numeral number 3 is saying, we need to calculate the acceleration of the car. Now since we know that acceleration is equal to what? Let me say force is equal to what? Mass times what? Acceleration. So we can make acceleration the subject of the formula, where we are going to say acceleration is equal to what? Mass divided by what? Force. Mass divided by what? Force. So in this case here, we are going to say acceleration is equal to mass, which is what? 800 kgs divided by, let me say, yeah. So we can say here we are calculating the acceleration. So we are going to say mass, which is what? Yes, mass, which is 800 kgs. Okay, 800 kgs. Yes, 800 kgs. Okay, let me do this. Acceleration is equal to what? Force divided by what? Mass. Yeah. So acceleration is equal to what? Force divided by what? By mass. So our force here we have 400 newtons. Then the mass here we have 800 kgs. So our acceleration here is going to be 400 newtons divided by what? 800 kgs. Then our acceleration here is going to be what? 0.5 meters per second squared. So don't forget to put the correct units here. Okay, so the next one, which is question B4. Yeah, it is coming from work, power, or work, or energy, work, and power. So this question is saying figure B4.1 shows a crane at a construction site raising a steel block of mass 100 kgs through a vertical height of 16 meters in 20 seconds. So now in this case here, let's try to correct our data here. So our mass here, it is what? 100 what? Grams. Then our height here, it is what? 16 meters. And then the time here, it is what? 20 seconds. Now, in this diagram here, we have been given the power input, which is what? 1000 watts. So we can say power input is what? 1000 watts. Now, the first question here, it is saying, which is question A. We need to calculate the what? The work done by the crane. So now, work done here. The work done here, it is done vertically, which means this one here, it is going to involve now the gravity. The gravity, which is going to act downward on the steel block. Okay, so here I'm going to say, since I know that work is equal to force multiplied by distance. Now, in this case here, distance is in form of what? The height. So I'm going to say work is equal to force multiplied by height. Now, in this case here, since I know that force is equal to mg, or mass multiplied by acceleration. Now, in this case here, we are going to take the acceleration as the acceleration due to gravity, which is what? 10 newtons per kgs. So I'm going to say, in the place of force, I'm going to put mg. Since I know that force is equal to what? Mg. The reason why I'm putting mg here, this is because work is done vertically. As a result, there will be the gravity which is going to act downward on the steel block. So I'm going to say the formula for calculating the work done here is going to be work done is equal to mgh. Okay, so now let's try to calculate now our work done here. So work done here is equal to, what is our mass here? Our mass here, it is what? 100 what? Kgs multiplied by gravity, which is what? 10 newtons per kgs multiplied by the height, which is 16 meters. So our final answer, which is work, is going to be what? 16,000 joules. So the SI units for work are joules. So I'm going to say 16,000 joules. So that one is the what? The correct answer for Roman numeral number what? 1. Okay. So let's move on to the next one. This is Roman numeral number 2. Is saying the power developed by the crane. Here they are asking you to calculate the what? The power output. So power is equal to what? The work done divided by what? The time. So in this case here, according to the data that we have been collected here, we have time, which is what? 20 seconds. And also we have work, which is what? 16,000 joules. So I'm going to say power is equal to 16,000 joules divided by 20 seconds. Then our power output here, it is going to be what? 800 watts. So in this case here, power is measured in where? In watts. So I'm going to say power is equal to 800 watts. Okay, let's move on to the next one, which is question B. Question B reads, given that the power input to the motor is 1000 watts, calculate the efficiency of the crane. So now on this part here, the efficiency of something, or the efficiency of the crane, it is how much percentage this motor is going to produce. Is it 100% or below 100%? Okay, so most of the time the efficiency is going to be less than 100%. This is because some of the energy will be lost due to what? Friction. Okay, so I'm going to say efficiency is equal to what? Power output divided by what? Power input. Okay, so power output divided by what? Power input. So in this case here, what is our power output? Our power output here is going to be what? 800 watts. Then the power input here we have 1000 watts. 1000 watts is our power input multiplied by 100%. Okay, so here I'm going to calculate. So my answer is going to be what? My answer is going to be 80%. Now this 80% is less than what? Is less than 100%, which means 20% of energy was lost due to what? Friction. So our efficiency is what? 80%. Okay, let's move on to the next one, which is question B5. So question B5 reads, figure B5.1 is a graph showing the variation of temperature in degrees Celsius with time second when frozen water is heated from for some time. Okay, let me repeat. Figure B5.1 is a graph showing the variation of temperature in degrees Celsius with time in seconds when frozen water is heated for some time. Okay, so on this part here, as for point A, as you can see here, we are having on the y-axis we are having temperature in degrees Celsius. Then in the x-axis we are having time. So now on point A, the temperature here was 0 degrees. So we can say on point A we are having the melting. Okay, on point A it is what? Melting. Then as for point B, we are having the temperature of 100 degrees Celsius, which means this one here, it is the what? The boiling point. Now the first one here, it is which is the first question, which is question A, saying what physical change was happening to the water at the point labeled D. So here at point labeled what? A, this frozen water was melting. This frozen water was melting. Since the melting point of the frozen water, it is 0 degrees Celsius, which means on this part here, the frozen water was what? Was melting. Okay, then as for B, question B is saying, in which state is the water at point A, let me say, at point between A and B. In which state is the water at the point between A and B? So now as you can see here, I'm going to say at point A and B, the water, yes, the water was in liquid and gas. Okay, so at point A and B, the water was in liquid and gas state. So I'm going to say liquid and gas. Okay, so as the frozen water is heated, you're going to find that it is going to melt. It is going to do what? It is going to melt. The result, a liquid, which is water, is going to be produced. Now, at point B, this point here, it is the what? The boiling point of water, which is 100 degrees Celsius. Now, at 100 degrees Celsius, we are going to find that the water is going to do what? Is going to evaporate in form of what? Water vapor. So that's the reason why I'm saying here we are going to have what? Liquid and gas. Then as for question C is saying when the temperature starts to rise, when the temperature starts what? To rise, which means when the temperature starts to what? To increase, the volume initially decreases. The volume initially what? Decreases and then increase. State the reason for this observation. So I'm going to say on this part here, you're going to find that the particles, when they are gaining what? Kinetic energy, they are going to move far apart. Okay, so now when they don't have kinetic energy, the particles are going to do what? To be closely packed. So I'm going to say this is because when the particles don't have what? Enough kinetic energy, they are going to be closely packed, but when they gain kinetic energy, they are going to be far apart. Therefore, the volume will be increased. So here I'm saying, once the water or the particles don't have kinetic energy, they are going to be closely packed together. But if they gain kinetic energy, they are going to move far apart. Because of that kinetic energy, they are going to move. Okay, they are going to move far apart. Okay, so let's move on to the next one, which is question B6. So question B6 is saying, figure B6.1 shows a ray of light traveling from glass to air at an angle. So the refractive index of glass is 1.52. So the refractive index here, it is denoted by small letter n. So the refractive index is denoted by small letter n. So I'm going to say refractive index is equal to what? 1.52. Okay, so now in this diagram here, the first question, as you can see in the diagram here, we have the ray of light and also the semicircular glass block. Okay, we have the semicircular glass block. So what was happening here was like this. The ray of light was coming from the less dense medium. So in this case here, we can say the air is less dense medium, is a less dense what? Medium. When you say less dense medium, which one is dense between air and a glass block? We are going to find that a glass block is denser because there the particles are closely packed. But in air, the particles are far apart. Okay, so the first question here, it is saying what? Define critical angle. Define what? Critical angle. Now, before I define the critical angle here, as you can see, this labeled part N is called what? The normal line. This labeled part N, it is called what? The normal line. Okay, so the angle which is going to be formed between the normal line and also the ray of light, which is the incident ray, is going to be called as the angle of incidence, which is this one here. Now, as you can see here, this ray of light was coming from less dense medium, and it passes through the what? And it passes through the what? The normal. After passing through the normal, as you can see, the angle that is going to be produced there, it is going to be what? 90 degrees, like this one here. Now, you are going to find that When you talk of the critical angle is the angle of incidence when the angle of refraction is what? 90 degrees, like this one here. So this angle here, which is going to be formed between the normal and the refracted ray, it is going to be called the what? The angle of refraction. So the angle of refraction here is what? 90 degrees in the diagram, like this one here. Okay, so I'm saying the critical angle is the angle of incidence when the angle of diffraction is 90 degrees. So the critical angle is the angle of incidence when the angle of diffraction is 90 degrees. Then apart from that one, we have question B. So question B is saying, calculate the critical angle in figure B6.1. So now, here I was saying the critical angle is the angle of incidence when the angle of refraction is equal to what? 90 degrees. So in this case here, I'm going to say sine critical is equal to sine angle of diffraction over diffractive what? Index. Now since here I was saying the critical angle is the angle of incidence when the angle of refraction is 90 degrees. So which means in place of the angle of the sine angle of refraction on R, I'm going to put what? 90 degrees. So now when you punch on your calculator, you punch sine 90, you're going to get what? 1. So therefore, the formula for calculating the angle, the critical angle is going to be sine critical is equal to 1 over what? Diffractive index. So like the way I was saying, the diffractive index, it is denoted by small letter n. Okay. So in this case here, in the question, they have given us the diffractive index, which is 1.25. So now here we are calculating the critical angle. We are not calculating sine critical, but we are calculating the what? The critical angle, which means we need to make sine the inverse. So I'm going to say critical angle is equal to sine inverse, open bracket, 1 over diffractive index, which is 1.52. So when you divide 1 over 1.2, let me say 1 over 1.2, let me say 1 over 1.52, you are going to get what? 0.657894736. Okay, then from there now you punch on your calculator, shift sine the answer, which is 0.567894736. then the answer is going to be 41.1 degrees. So in this case here, the critical angle is going to be what? 41.1 degrees. So this one here, it is the angle. So don't forget to put what? The degrees. Okay. So the next one is question C, is saying state two conditions for total internal reflection to occur. So when you talk of total internal reflection, so for the total internal reflection to occur, the ray of light should move from less dense medium going to the high dense medium. So now as you can see here, the ray of light was traveling from where? From air entering the what? The glass block. So which means for the total internal reflection to occur, the ray of light should move from what? From the less dense medium going to the high dense medium. Apart from that one, the critical angle should be greater than the what? The angle of incidence. For the total internal reflection to occur, the critical angle should be greater than the angle of incidence, or the angle of incidence should be greater than the angle of refraction. Okay, so here I'm saying the critical angle should be greater than the angle of incidence, or you say the angle of incidence should be greater than the what? Since the angle of incidence, since the critical angle is the angle of incidence when the angle of refraction is what? 90 degrees. How do you understand? Okay, so the critical angle is the angle of incidence when the angle of refraction is what? 90 degrees. So here I'm saying the critical angle should be greater than the what? the angle of refraction. So the critical angle should be greater than the angle of refraction, or the angle of incidence should be greater than the angle of refraction. Okay, so the next one, which is question D, is saying give one application or use for total internal reflection. So as for total internal reflection, they use it in mileage. Okay, so total internal reflection is used where? Is used in where? In mileage. Apart from that one, you can say total internal reflection is used in what? In lenses during what? An experiment at school. So when you are doing an experiment at school to demonstrate how total internal reflection occurs, they are going to use what? Lenses. Apart from that one, this total internal reflection is used where? In medical what? Equipments. For example, if they want to see how your lungs are, they are going to use what? Total internal reflection to view how your lungs are. Okay, if they are having a problem or not. Okay, so let's move on to the next one, which is question B7. So question B7 is saying figure B7.1 shows an AC. So the word AC symbolize or denotes what? Alternating current. So AC denotes what? Alternating current. So figure B7.1 shows an alternating current, which is AC generator, with its main components labeled A and B. So we have part labeled A and B. So part labeled A, it is called the what? The split rings. Part labeled A is called the what? The split rings. Then as for part labeled B, it is called what? The carbon brush or commutator. So as for part labeled B, it is called what? The carbon brush or commutator. So the questions are saying, as for the first one, which is question A, is saying write down the names of the components A and B. So as for Roman numeral number 1, we are saying it is saying A. So as for A, I'm going to say the split rings. A is the what? The split rings. Then as for Roman numeral number 2, B, I'm going to say carbon brush or commutator. As for B, it is carbon brush or commutator. Then as for B is saying state 3 factors that increase the magnitude of the electromotive force, which is EMF, okay, produced by the generator. Now for you to increase the magnitude of the electromotive force, the first thing, you need to increase the what? The number of turns. When you talk of the number of turns, the number of coils that you are going to use. So the number of turns should be increased if you want to increase the magnitude of the electromotive what? Force. So you increase the number of turns. Apart from that one, you need to increase the what? The current. The current should be increased. The current should be what? Increased. Apart from increasing the current, you need to increase the what? The number of rotation. So the number of rotation should be increased for you to increase the magnitude of the electromotive force. So I'm saying the first one, you need to increase the number of turns. Then the next one, you need to increase the what? The current. Then the last one, you need to increase the what? The number of rotation or rotation. Then as for B8 is saying figure B8.1 shows an electric circuit with a 5 ohms resistor R connected to a 12 volt supply. So we have instrument V and instrument A, and also instrument what? S, and resistor R. So before I answer the questions, these batteries, they are supplying what? 12 volts. This 12 volts is coming from where? From the batteries. So before I answer the questions, let me try to label the instruments. So as for instrument A, this instrument A, it is called the ammeter. Instrument A is called the what? The ammeter. And the ammeter, it is usually connected in series. So the ammeter, it is usually connected in where? In series. Then the function of the ammeter, or the use of the ammeter in the electric circuit, it is to measure the electric current. Now, as for the electric current, it is denoted by capital letter I. So the electric current is denoted by capital what? I. So as for electric current, it is measured in where? In amps or amperes. Then as for instrument V, it is called the voltmeter. Instrument V, it is called the what? The voltmeter. And the voltmeter, it is usually connected in parallel. So the voltmeter, it is usually connected in where? In parallel. So the function of the voltmeter or the use of the voltmeter, it is to measure the voltage or the potential difference. So now voltage is measured in where? In volts. And voltage is denoted by what? Capital letter V. Okay. So now as you can see, these battery cells, they are producing what? 12 volts. Okay. So which means these 12 volts will be shown on instrument what? V as 12 volts. Then as for instrument S is called the what? The switch. Specifically, this one is the what? The closed switch. Okay. So the first question, which is question A, is saying state Ohm's law. State what? Ohm's law. Now, before I state Ohm's law, let me try to write the formula, which I'm going to use now to give you what Ohm's law is. Okay, what Ohm's law is. So I'm going to say current is equal to what? Voltage divided by what? Resistance. So as for resistance, it is usually measured in ohms. Okay, so since here I'm saying current, which is capital I, is equal to voltage over resistance. So as for the resistance, we denote it by using capital letter R. So now, Ohm's law states that the current flowing in a conductor, it is directly proportional to the voltage or the potential difference when the temperature remains constant. So if the temperature remains constant, you're going to find that the electric current will be directly proportional to the voltage or the potential difference. Apart from that one, you can say the current flowing in a conductor, it is inversely proportional to the resistor. So right on this part here now, we are going to use now, according to the formula here, we are saying current is equal to what? Voltage divided by what? Resistance. So current is directly proportional to the voltage and inversely proportional to the resistance. So the next one I can say current is inversely proportional to the resistance provided that the temperature remains constant. Okay, so as for question B, which is the next question, Roman number 1 is saying calculate the reading of the instruments labeled A and V. So as for instrument A, it is the what? The ammeter. And the ammeter, it usually measures the what? The electric current. Electric current, it is denoted by capital letter I. So now in this question here, on the circuit diagram, we have two things which we are going to use, which can help us to calculate what? The electric current. Since we know that electric current is equal to voltage divided by resistance, and the voltage on the diagram, on the circuit diagram, it is 12 volts. Then the resistance on the diagram here, it is 5 ohms. So I'm going to say current is equal to 5 volts divided by 5 ohms. Then the answer is going to be 2.4 amps. Like the way I was saying, current is measured in where? In amps or amperes. So I'm going to put capital letter A to denote the what? The amps or amperes. Then the next one is saying we need to give the reading of the instrument V. So as for instrument V, it is called the voltmeter. The voltmeter measures what? The voltage. And then here I'll say batteries, they are producing the what? These battery cells, they are producing what? The 12 volts. So which means these 12 volts will be shown on instrument V. So in this part here, I'm just going to write 12 volts. Then the next one is Roman number 2 is saying, what is the cost of using resistor R for 6 hours a day for 30 days if power costs 15 ngwe per kilowatt? So they are using this resistor R for 6 hours a day for how many days? 30 days. So now for us to know the actual time they are using this resistor R, we are going to say 6 multiplied by 30, then the time is going to be what? 180 hours. So now when you are calculating the cost of electricity here, the first thing you need to calculate what? The energy. So here I'm going to say energy is equal to power multiplied by time. Now here the condition is like this. Power is going to be made in where? In kilowatt. Power is going to be measured in kilowatt. Then time is going to be measured in hours. Then the energy is going to be measured in kilowatt hour. Okay, so I'm going to ask myself, do I have power here? I don't have power. So there is a need to find power here. So since I know that power is equal to voltage multiplied by current, power is equal to voltage multiplied by current, or you can say power is equal to voltage squared, which is V squared over resistance. So from these two formulas, you can use one of them. So now I'm going to use the first one, which is power is equal to voltage multiplied by current. So in this question, we have power is equal to, what is our voltage here? So the voltage here in this diagram here, we have 12 volts. Then the current, I'm going to use the current that I've already found on question B, Roman numeral number 1. Okay, so the current here we have 2.4 amps. We have 2.4 amps. Okay, so on this part here, I'm going to say power is equal to 12 volts multiplied by 2.4 amps. Then the answer is going to be what? 28.80 watts. 28.80 watts. Now remember, here I was saying power should be measured in kilowatts when you are calculating the cost of electricity. Okay, so now what you need to understand here is that 1 kilowatt is equal to 1000 watts. 1 kilowatt is equal to 1000 watts. So in this case here, if I want to convert 28.80 watts into kilowatts, I'm going to divide 28.80 watts by 1000. Then the answer is going to be 0.0288 kilowatts. So now let me calculate now the energy. Since I know that energy is equal to power multiplied by time, so I'm going to say power, let me say energy is equal to power, which is 0.0288 kilowatt multiplied by the time. So in this case here, the time we have 18 hours. So when you multiply, or when I multiply, I'm going to get what? 5.184 kilowatt hour. So this one here, it is our energy. This one here, it is our energy. Now, how it is here is like this. The cost of electricity, the way they sell electricity, they are going to sell electricity in kilowatts or in units. They sell electricity in what? In units. So 1 kilowatt hour is equal to 1 unit. 1 kilowatt hour is equal to what? 1 unit. Now in this case here, they are selling 1 unit. They are selling 1 unit at 15 way. Now when you are calculating the cost of electricity, what you need to understand here is that the amount of money should be in kwacha. Okay, so the amount of money should be where? In kwacha. So now you're going to ask I'm going to ask myself now, how many ways makes up 1 kwacha? How many ways makes up 1 kwacha? So 100 ways makes up 1 kwacha. So if I want to convert 15 way into kwacha, I'm going to divide 15 way divided by 100. Then the answer is going to be what? 0.15 kwacha. 0.15 0.15 kwacha. So that one is going to be now my amount of money. So here I was saying 1 kilowatt hour is equal to 1 unit. Now they are selling 1 unit or 1 kilowatt hour, which is 1 unit at 0.15 kwacha. So now we have already calculated the what? The energy, which is what? 5.184 kilowatt hour. Then here I was saying 1 kilowatt hour is equal to the amount at which they are selling 1 unit, which is what? 0.15 kwacha. So since I know that 1 kilowatt hour is related to 5.180 kilowatt hour. So the kilowatt hour and the kilowatt hour, they are going to cancel each other. Then here I'm going to cross multiply. So 1.5, let me say 1.5, let me say 5.184 multiplied by 0.15 kwacha. Then the answer is going to be, or the cost of electricity is going to be what? 0.7776 kwacha, or you can say 0.80 kwacha. Okay, so that was the last one. So on this part here, you need to show all your working for you to get what? 3 marks. So the next one, which is question B9. So this question B9 is coming from radioactivity. So the question is saying figure B 9.1 shows radiations P, Q, and R passing through an electric field. So now when you talk of radiation, we have 3 types of radiations. We have 3 types of what? Radiations. The first one being is the alpha radiation, followed by the beta radiation. Then the last one we have gamma radiation or Y-ray radiation. Okay, so now those types of radiation, I'm going to start with the first one, which is the alpha radiation. So the alpha radiation, it is positively charged in nature. Okay, so the alpha radiation is positively charged in nature. So now since it is positively charged in nature, which means it can be affected by the electric field. Now when talk of the electric field, you're talking about the positive charge and also the negative charge. Then here I'm saying the alpha radiation, it is positively charged, which means likely poles or likely terminals, they are going to do a thing, they are going to repel, like positive and positive, they are going to do a thing to repel, but positive and negative, they are going to do a thing, they are going to attract. So which means on this part here, when the alpha radiation is affected by the magnetic field, it is going to bend toward the negative charges or the negative charge. Okay, apart from that one, the alpha radiation has the nature to that of helium. Okay, so the alpha radiation has the nature to that of what? Helium. Apart from that one, the alpha radiation, it has high ionization or strong ionization. So the alpha radiation has this strong ionization. So let's move on to the next one, which is the beta radiation. So the beta radiation, it is usually negatively charged in nature. So the beta radiation is negatively charged in nature, which means it can be affected by the electric field and also the magnetic field. So now since here I'm saying the beta radiation is negatively charged in nature, which means when it is affected by electric field, we are going to find that it is going to bend toward the positive charges, like the way P is bending to the positive what? Charges. Okay, so as for P, it is the beta radiation. Then as for R, it is the what? The alpha radiation. So now as for the beta radiation, it has the nature to that of an electron. So beta radiation, it has the nature to that of what? An electron. Okay, so as for beta radiation, it has weak ionization. Beta radiation, it has what? Weak ionization. Okay, so the last one is the gamma radiation. So gamma radiation, it is neutral. in nature, which means it has a zero charge. As a result, this gamma radiation, it is not affected by the magnetic field and the electric current, which means this gamma radiation is going to travel in a straight line, like the way Q is traveling in a straight line. So as for Q, it is going to be what? The gamma radiation. Now, the first question, which is question A, is saying identify the emission P and Q. So I'm going to say P, it is called the beta emission. Then as for Q, I'm going to say Q, it is the gamma emission. Then as for, so B is saying give one use of emission Q. So emission Q is called the gamma emission or Y-ray emission. So now as for gamma emission, it has the high penetration. As the result, it is used in the treatment of cancer or in the treatment of cancer cells. Apart from that one, it is used in the sterilizing of equipment C at the hospital or at the health center. Then as for question C is saying mention two differences between emissions P and R. So as for emission P, it is the what? The beta emission, and emission R, it is the what? The alpha emission. So here I was saying beta emission or radiation, it is negatively charged in nature. As the result, it is going to bend toward the positive charges. It can't bend toward the negative charges because like the terminals, they are going to do what? To repel. And unlikely terminals, they are going to do what? To attract. As the result, P is the what? The beta emission or radiation. Since it is negatively charged in nature, it is going to be attracted to the positive charges. So I'm going to say P is positively charged while R, let me say P is negatively charged. P is negatively charged while R is positively charged. Apart from that one, I'm going to say P as the nature to that of an electron, while R as the nature to that of what? Helium. Apart from that one, you can also talk of the penetration. You can say, since R is the alpha emission, then as for P, it is the beta emission. You are going to say P can be stopped by a sheet of aluminium. P, which is the beta emission, can be stopped by a sheet of aluminium, while R can be stopped by a sheet of paper. So this one is the last one for section B. Let's try to answer the questions from section C. So I'm going to start with the first one, which is question C1. Okay, so this question C1 came from travel graph, and it was saying figure C 1.1 shows a velocity time graph of a car of mass 1,200 kgs. So here the mass we have, let's correct the data. So our mass here we have 1,200 kgs. Okay, so the maximum velocity, it is 30 meters per second. Then the maximum time here we have 8 seconds. Now the first question, which is question A, is saying calculate the acceleration of the car in the first 2 seconds. Now when you talk of the acceleration is the change in velocity with time. The change in velocity with time, or the rate change of velocity. When you say rate, which means you're talking about what? Time. Okay, so acceleration is the change in velocity with time. So acceleration can only be done when the velocity is changing and also the time is changing. Now, if the time is changing and the velocity is not changing, which means there will be no acceleration. As the result, the acceleration is going to be what? 0. So in this case here, I'm going to say acceleration is equal to final velocity minus initial velocity divided by time. So in the question, they have given us time, which is 2 seconds. Okay, then the final velocity here we have 30 meters per second. Then the initial velocity where the car is starting from, it is what? 0 meters per second. So 30 meters per second minus 0 meters per second, the answer is going to be what? 30 meters per second divided by time, which is 2 seconds. I'm going to get what? 15. Now this 15 here, it is the acceleration. Now you need to put the correct what? Units. So I'm going to say acceleration is equal to what? 15 meters per second squared. Okay, so that is the first question. Okay, then as for question B is saying explain why the acceleration is 0 meters per second squared between 2 seconds and 4 seconds. So like the way I was saying here, when the time is changing and the velocity is not changing, there will be no acceleration. As the result, the acceleration is going to be what? 0. Now what is going to cause that one? I'm going to say because the car was moving with constant velocity. As you can see, from 2 seconds up to 4 seconds, the car was moving with the same velocity, which is what? 30 meters per second. Okay, so I'm going to say the car was moving with constant velocity. Don't say with constant speed, just say with constant velocity. Then as for C is saying calculate the displacement of the car while its velocity was increasing. While its velocity was increasing, it is from 0 up to 30 meters per second, which is the speed, and the time it is what? 2. Now as you can see here, the shape, or let me say, when you're calculating the displacement or the distance on the graph, we are going to say area under the graph is equal to distance. The area under the graph is equal to what? Distance or displacement. So now as you can see here, when the velocity was increasing, we have the rectangle. Let me say the triangle, not the rectangle, but the triangle. So which means here I'm going to say the area of the triangle is equal to 1 over 2, which is half, multiplied by breadth multiplied by height. Okay, so our breadth here, it is this one here from 0 up to 2. Then the height, it is from 0 up to 30. So I'm going to say area is equal to 1 over 2 multiplied by 2, which is the breadth, multiplied by the height, which is the 30, which is 30. So I'm going to say 2 multiplied by 30, the answer is going to be what? Let me say 1 multiplied by 2 multiplied by 30, the answer is going to be 60. 60 divided by 2, I'm going to get what? 30. Now, on this part E, the first answer I'm going to say it is area is equal to 30 meters per, let me say 30 meters squared. Then I'm going to say therefore, displacement is equal to 30 meters. So the answer here is going to be what? This displacement is equal to what? 30 meters. Then as for question D is saying calculate the resultant force on this car during its acceleration. So you know what a resultant force is. Force is equal to what? Mass multiplied by what? Acceleration. So now in this case here, we have already calculated the acceleration, and then the acceleration was what? 15 meters per second squared. Then the mass of this car here, it is what? 1,200 kgs. So I'm going to say, let me do this. 1,200 kgs multiplied by 15. So the answer is going to be 18,000. Now here they are saying we need to calculate the resultant force. So force is measured in where? In newtons. and newtons is usually denoted by capital letter N. So I'm going to say resultant force is equal to what? 18,000 newtons. Then as for question E is saying distinguish between speed and velocity. So speed and what? Velocity. So on this part E, the differences between, or the difference between speed and velocity is that speed is a scalar quantity or scalar quantity. Speed is a scalar quantity and velocity is a vector quantity. So I'm going to say speed is a scalar quantity while velocity is a vector quantity. So that one is the what? The difference. Apart from that one, you can also give them the what? The definitions between the speed and the velocity. Okay. So as for speed, you are going to say speed is the change in displacement with time. Then as for speed is the change in distance with time. Okay. Then as for F, question F is saying calculate the displacement of the car for the whole journey. So calculate the displacement of the car for the whole journey. So like the one I was saying here, the area under the graph is equal to what? The displacement or the distance. So in this case here, the area under the graph here, it is the what? The trapezium. Okay, so here I'm going to use now the formula for calculating the what? The area of the trapezium to calculate the what? The displacement of the whole journey. So I'm going to say area of the trapezium is equal to half open bracket a plus b close bracket height. So in this case here, the height, it is what? 30. Then the value of a and the value of b comes from the parallel lines. So in this case here, we have two parallel lines. So the first one being is the line from the line from 2 up to 4 seconds. Then the next one we have from 0 up to 80 seconds. So now on this part here, the distance from 2 seconds up to 4 seconds, we are having what? It's 2. Then the distance from 0 up to 8, we are having what? 8. So the value of a is going to be 2, then the value of b is going to be 8. So on this part here, it doesn't matter if you, even if you say the value of a here, it is 8, it's okay. Okay, so I'm going to say 2 plus 8, I'm going to get what? 10. Then the height, it is what? 30. So I'm going to say the half of 30, it is what? 15. Then I'm going to say 15 multiplied by 10. 15 multiplied by 10, the answer is going to be what? 150. So I'm going to say area is equal to 150 meters squared. So I'm going to say therefore displacement is equal to 150 meters. So displacement is measured in where? In meters. Okay. So in this part here, let me try to answer section. Let me try to answer question C3. Okay. So question C3 is saying figure C3.1 shows an apparatus used by a grade 12 learner to detect radioactive emissions. Background radiation was among the emissions detected. Okay, so in an exam they can also ask you to give them the ways of detecting radiations. So the first one being is the GM tube. So the GM tube, you can use the GM tube to detect what? Radiation or the background radiation. Apart from the GM tube, you can use the Bob chamber. You can use what? The cloud Bob chamber to detect radiations. Apart from that one, you can use also the what? The scintillation counter. So when you use the scintillation counter is more like the way this one here in the diagram here. This one here is what? The scintillation counter. Apart from that one, you can also use the what? The photographic plates or fumes. Yeah, so those are the ways of detecting what? Radiations. Now, the first question, which is question A, Roman numeral number 1 is saying, what is meant by background radiation? So now when you talk of background radiation, it is the emission of radiations from the surrounding. or you can say the amount of radiation present on the surface of the Earth. The amount of radiations present on the surface of the Earth, or the emission of radiations from the surrounding. That's what in the background radiation. Then apart from that one, we also have Roman numeral number 2. So as for Roman numeral number 2 is saying, give one example of a background radiation. So I'm going to say emission of radiation from cosmic rays. So emissions of radiations from cosmic rays is an example of background radiation. Then as for question B is saying table C3.2 shows the results obtained from the experiment after taking an account of background radiation. So we have the first one, which is the count rate in counts per minute. So we have the original mass, which is 200, followed by 100, followed by 50, followed by 25, followed by 12.5. Okay. Then in time we have time should be measured here in minutes, or the time here we have been given in minutes. Okay. So we have 0, 30, 60, 90, and 120. So the first question, which is Roman numeral number 1, it is saying, plot a graph of count rate, count per minute against time in minutes. So now the first thing here, I'm going to guide you on how to draw a graph under radioactivity. So the first thing here, whenever you're drawing a graph, you need to use a pencil. Don't use a pen. Whenever you're drawing a graph, you're supposed to use a pencil, not a pen. Apart from that one, whenever you're drawing a graph should have a title. So in this case here, the title is going to be the graph of count rate, the graph of count rate, count per minute, or count rate, count per minute against time in minutes. Okay, so the graph or graph of count rate, count per minute against time in minutes. So now when you use capitalizers when writing the title, don't underline it. So when you use small letters when writing the title, you need to do you need to underline it. So now on this part here, they are saying we need to draw the graph of count rate. So which means the count rate is going to be found where? On the y-axis. On the y-axis. Then the time is going to be found where? In the x-axis. Now as you can see here, we are having the maximum or the original mass of the count rate to be 200 grams. So in this case here, I'm going to choose the number of boxes that I'm going to use. So in this case here, I'm going to use 8 boxes. So now for me to know what a 2 centimeters is representing on a graph, I'm going to say the original mass, which is 200 grams, divided by the number of boxes that I'm going to use. Okay, so on the count rate, I'm coming up with the the range. Okay, so on the count rate, I'm coming up with the the range. So I'm having the original mass of 200, and I want to use 8 boxes. So now those 8 boxes, they are going to help me to know what a 2 centimeters on a graph is going to represent on the count rate. Okay, so I'm going to say 200 divided by 8. Then the answer is going to be 25. So I'm going to say 2 centimeters in the y-axis, which is the count rate. It is going to represent 25. So I'm going to write 25, 50, followed by 75, 100, 125, 150, 175. Then the last one is 200, like this. So I'm saying I'm going to start with 0, the initial point, which is 0, followed by 25, followed by 50, followed by 75, followed by 100, followed by 125, followed by 150, followed by 175, followed by 200, which is the what? The original mass of the count rate. Now let's move on to the next one, which is the time here. So mind you, remember to write on the y-axis as the count rate, counts per minute. Then on the x-axis, we are saying on the x-axis we are supposed to put what? Time. So similar to this one here, what is the maximum? What is the maximum here? The maximum, it is 120. So now how many boxes, or what number of boxes should I use here? I'm going to use now 8 boxes. So I'm going to say 120 divided by 8, I'm going to get what? 15. So for every 2 centimeters in the x-axis, which is the what? The time in minutes, it is going to represent what? 15 units. So I'm going to say from 0, 15, 30, 45, 60, 75, 90, 105. Then the last one is what? 120. So now on this part here, it is just the what? The matter of plotting the graph. So I'm going to say I'm having 200, what? 0. So 200, 0, I'm going to start where? At this point here, which is what? 200. So I'm going to put a point at 200 in the count rate, or on the count rate. Then followed by 100, 30. So 100 is coming from the count rate, then 30 is coming from the time. So my point will be here. Okay. Then the next one, we have 50, 60. So 50 is coming from the count rate, and then 60 is coming from the time. So 50, 60 will be here. Then the next one, which is 25, 90. So 25, 90, it will be here. So 25 is coming from the count rate, then 90 is coming from the what? From the time. So the point, or my point, will be here. Then the last one, we have 12.5, 120. So 12.5, 120. So now, on this part here, I'm going to say, since 2 centimeters is representing 25 units, so for me to know, since in a 2 centimeters we have 10 small boxes, so I'm going to say 25 divided by what? 10. Then I'm going to get what? 2.5. Now this one here, it is 25. Okay, so I'm going to say 1, 2, 3, 4, 5. So at 0.5 here, so I'm going to start from what? 120. Then I'm going to move 5 steps. 1, 2, 3, 4, 5. So if I move 5 steps here, I'm going to find that I'm going to reach on 12.5. So my point is going to be here. So now on this part here, it is just now the matter of what? Connecting the dots. So I'm going to draw the curve like this one here. Okay, so the curve is going to look like this. Yeah. So the next question is saying, from the graph, determine the half-life. Now, the half-life is the time taken. The half-life is the time taken for the activity to be reduced by the original. Let me say, yes, it is the time taken for the activity to be reduced by half of the what? The original mass. Okay, so in this case here, the original mass here, it is what? 200. Okay, so in this case here, the original mass is what? 200 grams. Now, this 200 grams, the half, when you say half, it's like this 1 over 2. So now this 1 over 2, we need to find 1 over 2 of the original mass, which is 200. So 1 over 2 over 200, we are going to get what? 100. So 100 grams, I'm going to draw the dotted line from 100 going, or I need to draw a line touching a what? I need to draw a line coming from where? From 100 grams touching a curve. Okay, so if it touches a curve, I'm going to drop now the line so that I find the time. Since I'm saying half-life is the time taken for the activity to be reduced by half of the original. Okay, so I'm going to drop the lines. At the result here, I'm going to get what? 30 minutes. Apart from that one, I'm going also to find the half of 100. So the half of 100 here, it is going to give me what? 50. So the half of 100 is 50. So similarly on this part here, I'm going to do the same. I'm going to draw a straight line from 50 touching a what? A cave. Then the time here I'm going to get what? 60 minutes. Then the half of 50, I'm going to get what? 25. So similarly on this part here, I'm going to draw a straight line coming from 25 touching a what? A cave. Then the time is going to give me what? 90 minutes. Now, let me try now to find what? The half-life here. So as for the half-life, it is denoted by small letter t. So small letter t is denoting the what? The half-life. So half-life is equal to 30 plus 60 plus 90. Now, how many number of half-lives do we have here? How many number of half-lives do we have here? We have 3 number of half-lives. So now, for us to know the average half-life, we are going to say 30 plus 60 plus 90 divided by what? 3. Then the answer is going to be what? 30 minutes. So let's have an example. If here we had the 2 number of half-lives, we would have said 30 plus 60 divided by 2. Since we have 3, let me say, since we have 2 number of half-lives. Now, in this case here, we have 3 number of half-lives. So which means we are going to say 30 plus 60 plus 90 divided by the number of half-lives that we have, which is 3. So we are going to say 30 plus 60 plus 90 divided by 3. Then we are going to get what? 60 minutes. Okay. So 60 minutes is our what? Our half-life. Then apart from that one, Roman numeral number 2 is saying we need to find the fraction. What fraction we will have decayed at 120 minutes. Okay, now under 120 minutes, it is 12.5. Now you need to show it. So according to the table that we have been given here, the table, it is showing that at 120 minutes, the fraction was what? 12.5, or we can say 125 divided by what? 10. Okay, so 125 divided by what? 10. The reason why I'm saying 125 divided by 10, this is because they are saying the fraction. So which means we need to convert 12.5 into a fraction. Okay, so when you convert 12.5 into a fraction, it's going to look like 125 divided by what? 10. So that one is the what? The fraction which is going to decay. Then the last one, which is question C, is saying a nucleus of uranium which is 235 emits 1 alpha particle to form thorium by the symbol of capital letter T and small letter h. Write an equation for the decay. So now when you talk of alpha decay, alpha particle has the nature to that of helium. So on this part here, we are going to use the symbol. So uranium is undergoing what? The alpha decay. So I'm going to write uranium, which is represented by capital letter U. The mass number, it is what? 235. Then the proton number, it is what? 92. Then this uranium undergoes decay by forming what? Thorium. So now what usually happens here is that what is going to happen is that the mass number of uranium will be reduced by 4 of the mass number of uranium. Let me say, yes, helium. Since we know that helium has the mass number of 4, which means uranium is having the mass number of 235. So, since uranium has the mass number of 235, which means the mass number will be reduced by what? By 4. Always, when you're writing the alpha decay, the mass number of any given isotope will be reduced by what? By 4. Since the alpha particle has the nature to that of helium. Okay, so as the result, the mass number of thorium will be 231. Then the proton number will be reduced by 2, since helium has the proton number of 2. So always when you're writing the alpha decay, the mass number of a given, the proton number of a given isotope will be reduced by 2. So I'm going to say 92 minus 2, then we are going to get what? 90. So 90 will be the proton number of thorium. So I'm going to say uranium undergoes alpha decay to form thorium, which is 231. Then the proton number, it is 90. Then I'm going to say plus the nature of iridium. So the nature of iridium here, I'm just going to write iridium itself. So capital letter H, small letter e, then the mass number we have 4, then the proton number we have 2 plus energy. So that was the last one. So remember to subscribe to my YouTube channel. Thanks for